Hello, welcome to Data Diving Dude. Quick channel intro for you. On this channel, we're going to be looking at different, data analysis of different topics. Here's a League of Legends data set on the screen here in Microsoft Excel. But we're going to look at all these different topics and try to do some data manipulation, answer some questions that we have about this. This isn't going to be the most thorough data science channel out there, most thorough data science operations, but this is trying to be like not like too surface level, but deep enough to where we do a good and thorough job on each of these statistical analyses, but also concise enough to where it's for more of a general audience and not just for a bunch of data science nerds. I'm not throwing out a bunch of data science terms out there. I will be obviously using some of these data science terms, but I'll try to do my best to define them and present them in a way that they're easily understood. So we're going to be using right now primarily two programs to do our data manipulation stuff. We have Microsoft Excel as we're showing here. This is League of Legends data that I found on this website, and for the pros. So we're gonna have a League of Legends video that I use this data for, and then the second program we're going to be using, this actually does most of our data analysis here, is R Studio. R is a data scripting language. You can also use Python. There's a bunch of Python environments out there, but we're going to be using R Studio probably for the majority of our data science endeavors here. And this is not like hardcore data science. Like there's like more hardcore machine learning, neural networks, that kind of stuff that we probably won't go into. But this is surface level enough to where you can get a concise but detailed glimpse of what the data is showing in some of these instances here. So, for example, this is a basketball data set here, and this is just a list of the columns. And then I wrote this data index here to help remind me what they were. But yeah, I mean that's basically it. So like we have offensive 2-point percentage right here. That's that column right here. It's a number. Here are some values. Blah blah blah. So that's just the data output. So when we look at columns, it'll be through this. The other, and we're going to be using two main methods of analyzing data and trying to predict results. The first one is called a GLM, generalized linear model, and what that is linear regression basically. So if you remember y equals mx plus b, this is basically that on steroids. So this basketball is. Can we predict how many, and this is kind of a stupid example that I just threw together just for the purposes of this intro video, but can we predict how many wins from these different columns right here? So this intercept is the plus b, so it's like saying add 2.17 wins, and then we have all our variables. This is the slope. So for example, for each point in offensive efficiency, adjusted offensive efficiency, we expect our wins to go up by 0.14 wins. For every point we gain in adjusted offensive efficiency. So that's one example here. The other important columns is this PRT thing. If you don't really know anything about t-tests or statistical significance, it's fine. But basically, the more stars there are here, the more statistically significant this value is, and the smaller the PR thing, the more statistically significant this variable is. So defensive free throw rate is significant as well as these four variables are the most significant to predicting wins according to this model here. So we're going to be using this kind of linear regression in a lot of stuff here. I'll try to explain it more thoroughly as we go into each individual case as to what a lot of this shit means. But basically the overall thing is you kind of want to determine like what effect each of these variables has on our the variable we're investigating, in this case wins. This is college basketball, by the way, and the significance of those. So now we have another thing called decision trees. This is a regression tree where I try to predict the seed they're going to be in the bracket and in the March Madness bracket. And you start at this top node, you move left if it's yes, you move right if it's no. And if you know nothing about the team, you just say, okay, 8.8, that's the seed we're going to go with. which seems a little odd, but I think we might be missing some teams here. But and then if we know our adjusted offensive efficiency, we can use one of these two branches to try to get more information about our seeds. And again, this is a pretty simple tree model. A lot of our tree models will be around this simple because and this is a regression tree. Most of the time, we're gonna have a binary classification, like whether you win or lose a particular game. But basically, you don't want it to be too complex because then it's not good for the real world. It's something called overfitting, which basically means that your model is so complex it'll work for your data set only, but not actually in the real world. It's like a little too complex. And plus, if it's too complex, it's too hard for people to follow, and for us to actually glean any knowledge from it. So looks like the seed is just based on offensive and defensive efficiency here, but this is just a basic example. This is a pretty bad example of like the usefulness of a decision tree here, because this is not the right kind of data for it, unfortunately. But we will have some examples with the right kind of data for decision trees, and I'll try to explain those as we go along. So yeah, this intro has gone a little bit longer than I wanted, but hopefully you get a general idea of what we're going to be exploring on this channel. Peace out.